Right. Good afternoon. Thank you so much for joining us for this session. Thank you so much for Phil, Joe, and the team for the ComSum because I've been speaking at ComSum for a few years now, and it's one of the conferences I love. I always say to Phil, I would visit here even if you don't accept my paper submission. Wonderful time. So this talk, just to set the scene, what is this going to be? How is it going to benefit you? Say, if you're here new to serverless, thinking, how can I go back to my team or organization, tell my boss, serverless is the way to go, or tell your CTO. You probably will find things from this talk that you can learn, understand, take it back. If you're already doing serverless, it's good. You may find things, wish we did that way, or, that's a good point, so I will go back and talk to my engineers. So you will find things on that front as well. And also, if you've been doing serverless for many years, you think you're a pro, expert, you can meet me later, say, Sheen, that part, you should have done that other way, because we have the proof, and let's share and learn. So that's all it's going to be. My part today is more of a preachy theory, whereas Lee will come on later, talk about more hands-on stuff that, how he develops, implements serverless stuff. So who am I? I'm Sheen Brisals. I'm one of the AWS serverless heroes. I am a part of the the Lego group. And also, these days, I'm busy writing a book with my colleague, Luke. So this is almost there, expecting January, February next year. So that's sort of our release schedule. This talks a lot about enterprise scale adoption and what are the best practices and things that you need to follow, etc. Right. And before I hand over to Lee, two things. Lee is an awesome engineer. He's been part of our team for more than a year now. And other thing about Lee is almost every day, at least once, he will remind us that he's a northerner. So I'm so happy that he is on his home territory, where he grew up. I think it's not far away. So please welcome Lee.
Thank you for that, Sheen. Apart from the fact that I'm from Huddersfield, and that's not kind of liked around here, I'll just sort of skip over that bit. But so my name is Lee Priest. I am an engineer at the Lego group. I work quite closely with Sheen on a daily basis, so really lucky in that fact, having the AWS hero himself to sort of bounce ideas around with. And you'll notice under there, I am also an AWS Community Builder. Was lucky enough to be selected as part of that program earlier this year, which is a great program. If you've not heard of it, have a look after this session. Really good stuff coming out of there. And you'll also see under that the term energy drinker. And it's actually quite a rare occurrence that I don't have a can of Relentless or Monster in my hand right now. But normally, if you saw me out on the street, that would be what I'd be doing. So let's jump in. So when you mention engineering and serverless and Lego group in the same sentence, you sort of get asked two common questions. So the first of these tends to be, is everything at the Lego group on serverless then? Short answer to that is no. Longer answer to that is, with it being the Lego group, it's such a vast company. We cover so many things from manufacturing through to normal IT day-to-day stuff that serverless might not be the best fit for everyone, but we are free to sort of use the technologies that we want to use. And every department sort of can choose their own sort of technology path. So the department that I sit under is what's called Marketing Channels Technology, or MCT, which sits under the larger sort of digital department within the Lego group. So within MCT, there's sort of three key areas. So you've got lego.com. I'm sure everyone's visited that site. Hands up if you've visited lego.com. Those with the hands down, I know you're lying. So yeah, lego.com, we all know it, we all love it, we all spend hours on there. retail stores, so our brick and mortar stores. Hands up if you've been in a Lego store. That's more like it. Cool. And then we've also got our customer support center. So anything goes wrong with a set that you might get, or if you've got any questions, anything like that, that's where you would head. So we've covered question 1. So then question 2 obviously then becomes, okay, so not everything's serverless, but how much of Lego.com is serverless? And well, I can't give you a straight answer on that right now because we've got more slides. So the serverless journey of Lego.com is quite an interesting one. So we switched to be serverless in 2019 on 10th July. You might be a bit suspicious as to why that's such a specific date, but we'll get into that. So we can see here a sort of overview architecture of what Lego.com looks like. Let's make that a bit easier on the eyes for you all. So we can draw in some nice boxes and separate these out. So we've got the icons at the front are the things that you good people would be browsing on your phones and all that sort of stuff to go onto the website. There is a ECS container on Fargate that I'll not talk about. And that's the sort of front end of Lego.com. And then you've got the stuff that I will talk about, which is the AWS Lambda-based microservices, which is sort of the brains behind Lego.com. When you've got all these really cool AWS resource icons, so you can see we have things like API Gateway, EventBridge, SQS, DynamoDB, one of my personal favorites, step functions, and all that will sort of combine to handle all the stuff you need, and it'll reach out to third-party payments and other commerce things and that sort of stuff. So I mentioned it's a bit of an interesting journey on how we got to the sort of serverless state that we're in. So November 2017, bit of an issue, legacy platform failure, fire everywhere, tears, crying, not a good time. So we sort of figured we can't really continue if we're going to have all these failures on this platform. So in spring 2018 is when sort of the serverless experimentation started. So you're starting with simple services, just getting a feel for the land and sort of working with it, getting used to serverless technologies. Then that sort of grew and matured and graduated into the release in 2019. So we started with 20 microservices that were split across 2 teams with 20 engineers. And then from there, it's just sort of grown and grown and grown. So we can see that we've got the payment service rollout where you've got new product squads that came along in the fall of 2020. We then realized in summer 2021 that peak traffic wasn't really a thing anymore because of the new product launches and the epic scalability that we now had running on serverless, that it was just sort of another day at the office. And then we allowed us to expand our team further to even better handle that. And then we sort of get to present day where we've got several microservices in different squads. So every squad's probably got several microservices. They've got multiple AWS accounts, and it's just going from strength to strength and growing and growing. So as the journey wasn't that straightforward, there's definitely some principles and essentials that you'll need to follow. And that is my segue to hand back over to Sheen.
Okay, so from here on, some of the lessons learned from my experience working with teams at the Lego Group, and also speaking to so many of you around the conferences and places where we used to meet. So, few things. Especially when teams adopt serverless, often there is mentality that serverless is so simple. Yes, it is simple, right? Anyone can write a Lambda function and deploy it, and it's there. But when it comes to larger scale adoption, when you think of your organization and when you think of how can you have multiple teams adopting one after the other based on their success, you need to be a little bit more careful. So this kind of a collective effort is not just the engineering team's responsibility. The first thing from an organizational point of view is that we should be able to accept change happening around us. Environmental change or technology change, it's happening all the time. If you go back a few years or few decades ago, mainframes ruled the the world. They still are, right? Now, from there on, the virtualization technology kicked in, and that really kind of triggered what we have, the cloud now, right? If you think of it. So all these things changes. Now, software engineers moved on, right? We're not kind of stuck with the mainframes or VMs. We kind of moved on. So change is always there. So we often say change is constant, but if you think of the technology, change in technology is fast because we demand for more features or more functionality, then change happens to satisfy us, then we never satisfy ourselves, right? So we ask more, cycle continues. That's what David Anderson and Mike and Mark beautifully wrote in this book, that organizations that they accept the change or the ones that drive the innovation because the power of the change. So that's a constant cycle happening. Now, second thing is, for serverless to become successful, we need to have the serverless mindset. Now, you hear this all the time, but what is it? Because the thing is, with serverless, we are not like programming like we used to. We are mostly composing services by using several cloud managed services. And we just kind of knit together with infrastructure as code. So this sort of the realization we need to have. We can't just say that, we didn't do this that way, a few years ago, but this is the reality now. So we need to accept that it's happening in the industry. Good old days, this is the typical waterfall model, right? So you go through these sort of siloed phases. But these days, it's a bit more faster. You get some idea, you quickly come up with something, you iterate, move on. You don't kind of, deliver an application and you think that's done with it. No, it's kind of living. So you're sustaining your application going forward. So that's why I often say that it requires new way of thinking from what we used to in the past. So this is important when we come to adopt serverless. So quite a few things like you need to align your business requirements with serverless, what serverless can offer, and you need to think like people say shift left when it comes to testing, security, observability, and the cost awareness is important, and the siloed team structure of the past goes away. I often say serverless engineers are kind of diverse engineers because they come with several skills, not just programming. They understand how to queue things. They understand how to secure stuff. They understand how event-driven architecture works, streaming, all sorts of things. Deployment, CDK or infrastructure, all these packaged now together as a serverless engineer. So these are all important aspects that we need to understand. Then comes the first principles. Now, you hear this serverless first mindset, serverless first approach, right? Now, as I said, serverless is not a silver bullet. If you just say serverless 10 times, it's not going to make any difference to your organization. Now, serverless first you hear all the time, but it does not mean that you just jump in right away and then make it a serverless must thing, okay? So when I say first principle, what is it? And again, in this book, Dave Anderson, they clearly explain what serverless first means. It's like you evaluate the problem with a serverless mindset, but doesn't mean that you always go with serverless. It depends on your workload and the application, use case, etc. Now, what is first principle thing? First principle thing is basically going back to the basics. You have your problem, you break it down, you identify the parts, and then you start from the the basics and see how best you can fit the technology in it. So there are a few things I would like to go through. I mean, if you don't pick up anything today, this is the one slide you probably want to take it with you. Before you get to doing anything serverless in your organization, think domain first. This is the typical domain-driven design most of you must be familiar with. So what does that give you? That gives you the breakdown of your organization or your division or department into domains, right? So you have loyalty domain or checkout or whatever. And it again depends on the organization. Some organizations break at a high level, some go further down, subdomains and things. So when you get to subdomains, you identify your bounded context. So Lee will be talking later on about loyalty service. Loyalty service is a bounded context as part of the loyalty domain because you have the loyalty experience and loyalty content and stakeholders and other things. So when you get to this level, it becomes easier to think in terms of teams. You assign team ownership to protect your boundaries, protect the bounded context, right? So these are the two pizza teams or whatever, the name you assign. Once you have teams assigned, then you can think of microservices or your applications to live inside each of those boundaries. Now, when you have microservices, you think of APIs and events because, again, protecting the boundary. You have contracts to communicate between the microservices. Again, not all microservices will have APIs. That's fine. In serverless, not all microservices will have even Lambda functions. You heard the talk earlier, So this comes in. And then event-driven architecture. After this, if you think of serverless, implementing the microservice or applications using serverless technologies, it will become much easier and manageable for the teams. Okay, so next thing is workload assessment. Again, enterprises, this is a critical phase that we need to go through in any organization. This is what I said. You shouldn't operate with the serverless must mindset when we look at serverless to do an application. The serverless first thinking should come in as an evaluation, not necessarily your first protocol for implementation, okay? So this is important. And in terms of assessment, two critical questions you should ask. Will this application perform efficiently or sufficiently? And then, will it be cost-effective overall? Overall is important because you don't want to compare your Lambda function with a EC2 instance. No. That's the sort of old way of thinking. You need to take the whole thing, entire application, the total TCO, the typical cost of ownership thinking, total cost of ownership. So that thinking should come in. Efficiently has different meaning in serverless because it's not always the latency, or it's not always the throughput. It depends on the use case or the service that you operate. Say two microservices, event-driven, right? So this microservice, its duty is to emit an event as soon as possible. Fine. So that way, this is efficient. This is a microservice. It consumes that event, but it has its own priorities. Doesn't mean that because that first microservice emitted as soon as possible, this is now going to process as quickly as possible. It may hold on to the event for a while. Because for this microservice, that is its sufficient way of doing its service. So it varies. That's why I'm saying that efficiency has a different meaning. Then business buy-in. Now, this everyone knows that. If you want to do modern application, you need to do modern technologies, right? So when it comes to business buy-in, this is where you communicate with your stakeholders a lot. Speak their language. Don't throw in the serverless jargons and things. Make them understand and showcase, show them the sort of things that you've done, and then highlight the cost benefits and invite them to any of the talks or demos and things. And importantly, take and show them examples from the industry. There are so many experience here, among you. So learn from each other and take the messages to the, stakeholders and show them, okay, company XYZ have done it perfectly. So why don't we learn from them or other companies? So these are all important aspects when it comes to adoption. Now, this is an important one or interesting one because these days there's quite a lot of talk about vendor lock-in, right? Because if nothing succeeds, then somebody will kind of raise the question, what about vendor lock-in? Then the whole thing collapses and they go to, the drawing board and start everything. The thing is, vendor to me is someone, sells these things. Of course, we should give some respect to everyone, but cloud provider is more than a vendor. You can argue that Amazon sells both, fruits and veg and cloud service as well, but the point is, it's not a vendor, it's a partner. Because as a cloud provider, your organization will work a lot with a cloud provider partner. Because you go through a number of things with a provider in terms of planning for your high season or getting some sort of a training or workshops and reviewing your design and architecture. So this is the reason why it's best to work as a partner rather than just considering as a vendor with a lock-in mindset. So the other thing is growing serverless teams. I give a separate talk on this one. So this everyone knows that people say that if you want to grow your company, grow your people. But how many places this happens? Now, the problem with serverless is, or with technology, obviously, not all organizations will have enough, the people with the right skills. So they bring in consultants, right? Nothing wrong. The problem is they get the products built, delivered, and they disperse the team because they are expensive, right? So when there is a new need for building something else, they do the same thing. So they just bring in and do the thing and repeat. The problem is the knowledge transfer never happens from the consultants or the experts to the employees inside, okay? So that is an area that every organization needs to address. Like Joel talked about inner sourcing. So these are all part of, developing the team or growing the engineers. And if there is no people growth, obviously, you can think there won't be any organizational growth, and technologies like serverless will also won't grow in such environment. There are several ways we can, grow engineers by giving them enough, freedom, take responsibility, give them to take responsibilities, and also offer them number of things. Conferences like this, good examples where people come together, share, and learn. Now, principles and practices are when you start kind of growing towards the implementation or, architecting phase. And Andrea mentioned the solution design. The reason for solution design, not just to produce the document, because the processes like solution designing allows engineers to think, come with ideas, discuss with experts, learn, review, iterate, improve. So that's, main reason for this sort of, the processes that we follow. Similarly, security and threat modeling. That's an important aspect of modern, software building. So again, brings in that, thinking. When someone logs to, a CloudWatch or wherever, these things make them think, oh, do I have PII data? Do I have sensitive data going? How do I prevent? What measures we have? So these are all part of, the process that we go. Then, of course, incremental and iterative development process. The MVP to MVP is not a typo. What I'm saying is like a minimum viable product. Your goal is to take it to and make it as a maximum valuable product. So that is sort of the way that we must be, moving forward. And observability and monitoring, as I mentioned, these are the, the things that you start from the, beginning. When you do your solution design, you think, what are the alerts and alarms that I need to, have for this particular service, or how can I observe, and what are the, measures I need to put in place. And finally, being sustainable. So I know sustainability is the, the talk of the point, but in our organization, you may have sustainability promises, and then you have the targets and how to achieve. But when it comes to serverless, I talk about the serverless sustainability triangle because there are three things I will explain. One is building sustainable products, and then following the sustainable processes, and of course, then operating sustainably in the cloud. Now, what I mean by sustainable products is not related to the sustainable environment, but my interpretation is a product that can live longer. You can sustain it with a little bit of touch and go and take it forward forever. So how do you do that? You need to build products that are extendable. How do you extend? You need to be this needs to be modular. How do you know you can extend and model? This needs to be observable. So these are the principles that make a product sustainable. Then of course there are a number of processes that you can adopt in terms of having a sustainable processes like lean principles and So all this, I'm not going to go through the details, but these are the principles and practices we need to follow. And then finally, sustainable cloud. So this is a shared responsibility. If you are familiar with AWS security principles, similarly, sustainability is a shared responsibility because AWS cloud can provide certain things as part of their operation, but on top, as consumers, we have our responsibility to do as well. So that's why they have the nice split. AWS look after the sustainability of the cloud, and we are responsible for the sustainability in the cloud. So there are several patterns and practices that we can do to improve that. I'm not going to go through the details. I just give you a simple example. Like we all know, most of you know DynamoDB, right? You can easily create a DynamoDB table. It costs nothing. I have few rows of data. It sits there idle for years. You don't care because it doesn't cost you anything. But do we realize that somewhere in the cloud, somewhere in a data center, there is someone holding that space for us? So these sort of thinking, even if it's simple things, these things needs to be kind of brought into the team so that they become aware when they solutionize, when they architect the solutions. So these are basically the principles. I think Lee will kind of do a recap later on. Now I hand over to Lee to talk more about the practicality of how building solutions, taking on board some of the practices I just mentioned.
Hello again, I am back. So I told you earlier about the journey of Lego.com into serverless, but I'm just going to pause for a second on this slide and sort of tell you my own journey into serverless. So back in 2020, in January 2020, I know we don't like to think of 2020 due to certain world events, but back in January 2020, I was as green as the slide background when it came to serverless. I had never touched a Lambda function, heard serverless as a buzzword, was mainly a front-end developer, and sort of had not a real clue about what it was. And then I joined the Lego group. I got working with Sheen and the other serverless engineers and people like that in the squads and stuff like that in the Lego group. And it's true what Sheen was mentioning about mindset shift and stuff like that. There is such a shift when it comes to looking at how you work as an engineer in terms of like the serverless side of things versus, especially when you come to front end. I don't know if anyone here has done front end. I imagine there's probably a few that have dabbled, but it's a very different sort of kettle of fish. So that was my experience as sort of coming into the serverless world, and then going on from there as I got into the loyalty service. Now, the loyalty service itself covers a few things. There's 4 main areas up on the screen right now. So we've got the Lego customer, the person that visits the retail store, as we've established that you all do, and most of you who visit the Lego.com website as well. We've got the loyalty program, the Lego Insider program, and that gives you the ability to earn rewards, so you can earn points, and you can then redeem those points for specific rewards that you might want. And you can then have your in-store experiences where you can complete purchases in-store, and you can then update your Insider account with your points and all that good stuff. So if we look at the sort of loyalty service and the loyalty squad in terms of what does it look like in a AWS resource microservice-y sort of context, we can see that there's quite a lot going on. So thankfully, we are an autonomous product squad, so we have this sort of freedom to look at the technologies ourselves and decide what sort of journey we want to go on, whether we want to use maybe a Lambda function for this or a DynamoDB for that. We do have one Fargate container, but that's because there was no serverless option with the thing we were connecting to, but as soon as we got that into our Fargate container, it then magically got pushed back into serverless world. So we have our own separate AWS cloud account within Loyalty. We've got our own GitHub repository. We've got our own pipelines. We work API first. We embrace event-driven architecture. So hopefully you can see that we are fully aware of our entire sort of context and our entire stack, and we're able to work as we best see. So if we have a look now at this loyalty service platform context a bit more, as I hope you remember from Sheen earlier, remember contexts, domains? We've got the services on here. So we've got some of the various microservices that we've got within the loyalty service context. So we've got order service, member service, etc. And then we can see over on that far end, we've got what we call anti-corruption layers. So these are the things that their sole purpose is to reach out to a third party, and then it will transform the data to then feed back into our other microservices. So then we don't have to sort of pollute our other services with logic that might not be directly related to their purpose. So I'll now take you through a couple of case studies. So the first one is to do with order orchestration. So there was a piece of work that we did recently where we wanted to handle non-insider orders. So in terms of orders, we technically have like two types. So you've got your insider orders, which is your signed up verified user that's coming into the store, placing their order, earning points. And then you've got your non-insider orders, so the people that aren't signed up but are still placing orders. So if we take a look at the order placement flow, we've got the customer that comes in to the Lego store. They will browse the Lego store, pick up the sets that they want, head to the till. They can select any rewards that they may have on their account, and then that order will get placed. It then gets sent through to our loyalty API, and from there, it hits our order service where those rewards are then applied to the account, and that's technically the order placed. So that's a high-level overview of sort of what happens in the order placement. So when we're thinking about, okay, we have this current setup where we're handling existing insider orders. So we need to be quite careful and take a considered approach when we're looking to modify that to handle sort of non-insiders. So we need to handle the non-insider orders. We also need to not disturb what's there currently, because we don't want to push this new stuff up there and break a pipeline that's handling thousands of orders potentially per day. And then we want to have some extra checks, so we're able to easily identify what might be an insider or a non-insider order, so then we can route our logic properly, and observability. You'll probably hear me talk quite a lot about observability today. I am known to go on a bit of a rant about that. Speaking of, so observability. I heard all the groans inside your heads, don't worry. I know that nobody wakes up in the morning wanting to strictly write logs or do that sort of thing, but it's worth it in the end. It should definitely be considered as one of the top things to look at when building up microservices and things like that. So observability is not just sticking a console log in and being done with it. It comes in a lot of different flavors, and just a few of these all add up. So structured logging, making sure you've got a nice structure for your log. So you've got your dashboards too. Everybody loves a pretty dashboard, so that's always a bonus. I mean, being able to see what's coming into your services, your throughputs, your memory usage, things like that. alerts and alarms, so you can know before anyone else if something's either starting to go wrong or is going wrong. Things like journey milestones and unique references are really, really powerful when it comes to observability. So if you've got one particular reference you can tie from a journey that started from a customer doing a lookup on their own email to then having that same reference present right at the very end once they've checked out at the store, you can then check every step of that journey and see exactly what's going on. Really powerful for debugging, really powerful just in general to be able to see that everything's working as it should. So going back to the customer order overview, we've got the order being placed in the store. We hit the loyalty API. That funnels it into our order service. So then we start processing the order and emitting an event that then gets picked up by the CRM service, which is that anti-corruption layer that I mentioned before that reaches out to the CRM and then gets its response back, and then the order's placed, and the process is complete. So this is what the original order processing flow looks like. So you've got your API gateway receiving that order. We've got a Lambda function that importantly returns a synchronous response, because if you think about it, you've got a Lego store, you've got a customer stood at a till, and you've got an attendant behind the till. They don't want to be stood there waiting whilst we're doing all our stuff in the background before they can finish whatever they're doing and go back about their day. So we return a synchronous response saying, yep, payload's all good, we'll take it from here, or we'll send back something like, oh no, this is wrong, check that, etc. So then once we've validated that, we then will dispatch an event that will run through to the order service, where we'll run things like step functions. We'll adopt a storage first pattern to make sure we've got a full audit trace. And then we use something that's called a task token. Anyone use task tokens before? Hands? A couple of people. So for those that haven't used task tokens before, I'll talk about it in the context of the step function that we're using it in. Basically, what happens is we get this task token and attach it to an event that gets sent out, and this pauses the actual step function execution, and that step function execution will wait until it gets a response back from that task token. So that task token is sent through to the CRM service that reaches out, talks to the CRM, then say CRM service comes back saying, yep, all good, fair enough, let's carry on. You're back to your order service, you tell the step function, cool, we're good to go, let's carry on. Processing continues, and then order is processed, send out an event, let everyone else know, all our other microservices. So we had to think, and we were sort of scratching our heads wondering, could we maybe just update the Lambda function or do something else like that? What we decided on was an express solution. So we came up with the idea of having a separate express step function. Importantly, express step functions are able to run synchronously, because remember, we need that synchronous response back to the till attendant and the customer so they can continue on their day whilst we handle our stuff. We can use things like VTL to configure the request and response, so we can easily match up any requests that come in to what might already be expected. And then we realized that this could actually execute before that giant order step function that we currently have. And things that express step functions are really good at is running short, fast tasks, and they're also really cheap to run. So this is what that step function actually looked like. So you've got nice, simple, and effective build there in the studio view, where you've got the specific paths for the insider and non-insiders. You've got one Lambda function per path that runs just a little bit of logic, and then they'll emit the event to sort of carry on the flow that we saw before. And they've also got good stuff like separate error handling, so we're then able to handle the errors based on if it's an insider or not. So then let's look at the updated order processing flow. We've got order coming in, API gateway. There's our express step function. Synchronous response is going back. And then I'll just cheat now and just carry on going through the rest. So when we think back to the goals that we wanted for this update, we have basically done that with editing like a single step within this entire flow on a system that's currently live in production. So what made this work? Work could be done in parallel. So we already had the existing flow up. We could work on this new step function in parallel to that carrying on. Did not disturb any of the existing functionality, which is always a bonus. And any changes that were needed to be made to any Lambda functions were very minimal, because things like looking at the event, there was just a case of a Boolean or just a tiny piece of data. And then we had deployment confidence too, because as this wasn't disrupting anything currently in production, we were fine to just be able to deploy and test, because it's not being hit by thousands of people and it's not being sort of used. So we were able to take it slow, make sure that our things were working all up in the different environments. And it allowed us to do independent piece deployment as well. So we didn't just have to build this extra step in and just sort of throw it up all at once. We could do it piece by piece, which is really, really handy. And then, as I said before, just a single choice step basically allowed this to work. So in the main order step function, there is a choice step that's like, is this insider, yes or no? If it's yes, go down the normal flow as it was before. If not, go down a separate flow. So that's the first case study. So this next one, this one circles more around event ingestion. So this is sort of the logical flow that we've got for this event ingestion. So what we have is a third party that we're wanting to take events from and then push that through to another anti-corruption layer where we are going to have. So we can set up an endpoint for that, use something like SQS maybe to sort of queue up these requests, then route that through to a Lambda function to do any logic that we need, and then push an event onto the event bus so then the rest of our services can ingest that themselves. So let's think about this and think about what we might need to do. So incoming requests, we might have a high volume of them. So maybe the SQS step was a good idea. Do not disturb, again, we don't want to impact any existing services. Any work we push up shouldn't break anything that's already there. We've got category-specific logic as well, as you will see coming up. And observability, don't worry, I won't go on my rant again, but think back to the slide where I said structured logging, always a good one. So this is the actual incoming event. Not sure how well you can see that, but basically what we have is a bunch of different things. So what can we see in the event? We've got the category, we've got extra data, so there's a extra data object there. There are a few unique parameters as well that are unique to this particular sort of category that we can maybe use. And we also need to think about size of the incoming events. Do we need to consider that when looking at our actual solution that we're going to come up with? And then we also, with that in mind, do we then need to think, can we use this resource or that resource? Can we use SQS to handle this? Can we use things like Kinesis to handle this instead? So these are some of the things that we could leverage. So we've got the API gateway, SQS and Kinesis there for handling the queues. We've got Lambda for any logic we might need to run, and obviously Event Bridge to pass out the event to our other microservices that are expecting that. So then a solution is born. So this is the solution that we sort of settled on in the end. So we've got that third party pushing that data in, the API gateway webhook that we set up, ingesting that in, passing that through to the SQS queue. Any errors in there will go into a dead letter queue. And then we have the Lambda function to perform the logic checks on things like the category. And we also run storage first again. So we make sure we've got full order history of the events that were coming in. And then we pass on the event to our other microservices. So although this looks like the solution for everything within this scenario, this is more of a pattern that we're going to use going forward with this, because we have this pattern now where we can ingest an event, run some logic, but if we want to be able to do real-time analytics on the data coming in, so maybe it's better to use something like Kinesis. And this would also maybe come from a different endpoint from the third party. So we have this pattern going forward that we can use to then tailor exactly how we need, which is always nice and simple when working with serverless resources. So you might be sitting there thinking, okay, what's the point? Like, why have this solution where you've got another microservice to maintain? Why not just chuck it straight into the existing ones? So as I mentioned, it's an anti-corruption layer, so it keeps this separate, keeps it contained. You have this point of contact for that data and handling that, and it's not polluting any other services that you might have and sort of disrupting their flow. You're ensuring compatibility as well, because this service is always going to pump out the same sort of event and same structure of event to your other services. And yeah, again, the dedicated service allows for the gradual adoption of new categories, because at the moment there's only one category that we've got. So we can then use this to go forward and gradually introduce more categories, and even things like introduce more consumers to the events. Keeps out of the services, as I said, small and concise. We're not polluting anything. And again, it just allows that gradual approach, and we're not throwing things up and expecting them to work and expecting people to migrate quickly. So what made this approach work overall? Again, simple, focused implementation, as you saw in the sort of logical flow. It wasn't the most complex of things, which can often be the best solution. Just nice, simple focus. We've got the choice of API gateway with SQS, allowing for that scalability. We've got the existing services not being affected. Deployment confidence, again, able to deploy it as it wasn't being hit by anything or anyone. And we're always embracing the event-driven approach, as I'm sure you've heard today is a very good idea. So another thing I want to quickly touch on is embracing ownership. So own your service. Don't just go out there, build a microservice, and then forget about it, pass it on to someone else. This is something you created. You're then essentially the owner of it. You can go through to the rest of your squad, the rest of your team, and be the point of contact for that service. Obviously, share with them, share the knowledge and all that sort of stuff. Don't hog it to yourself, but be confident and own your service. So just a quick recap on the adoption essentials. So accepting change, make sure that you're always ready to accept that a solution might not be always perfect, it might need to change. Adopt that serverless mindset and the adoption principles that come with that. Workload assessment, so assess the workloads that might be needed for a particular service or your resources. Business buy-in. Again, like Sheen said, don't just go to the business and use all the jargon. Make sure that they understand everything that you're trying to do. Cloud provider as a partner, so think of it as a sort of more mutual relationship. Growing engineers, and I can attest to that one. As I said before, completely green coming into the Lego group, and I've grown since then, partly due to the development practices as well, and also think about sustainability when creating things. Don't just throw things up and forget about them. And that is everything we've got for you today. Thank you very much for listening.
Thank you very much, Lee and Sheen. Awesome. I think we've probably got time for like a quick question. If anyone has a pressing question. Yep, you had your hand up first, so let's go and do that.
Thanks so much. I really enjoyed it. Both the case studies really interesting. Lee, I guess this question is probably best for you. For case study one, with those orchestrated workflows using step functions, I wanted to know what's your approach to testing? I guess both unit but also integration testing, because they're quite complex.
Yeah, so we do have a dedicated QA engineer that will run through any sort of thing that we will build, but we do, obviously you've got your unit testing for your logic within your Lambdas. We run testing ourselves when we're obviously building these solutions and making sure that we can test things in via something like Postman. We've got integration tests that will actually run through the step function itself, so it deploys it up to an environment and then will actually run through itself, so then we'll be able to see any logs in CloudWatch or the output in a console or something like that if it fails. So we've got fairly good visibility. Obviously, there's new error things that have just come out recently for step functions, which weren't available then but are now, so maybe something we can continue to look at as well. Cool.
Awesome. Anyone else while we're here? I think we're good. Thank you very much, guys.
Thank you.